In the previous two videos in this series, we have been creating connections between models in Rhapsody and Jama and using them to create a unified system model distributed across these tools. In this video, we will show several options for tracing and visualizing these connections. In the UAV model we have been working with, there are multiple connected tools beyond Jama and Rhapsody. The Connection Summary tab on the Sade dashboard provides a tabular view of all these intermodel connections, that is, the connections between models and different tools that Sade manages. According to the display, there are 83 stored connections. The Connection Summary has useful tools for searching, sorting, and filtering the rows. For example, filtering for Jama shows just the connections to Jama. We can also export the table as an Excel file. An alternative view of the intermodel connections is a chord plot, which can be launched from any element in the Rhapsody model or Sade dashboard by right-clicking and choosing Sade, Visualize, View All Connections. This opens a plot in your default web browser, where the circles on the periphery represent elements in Rhapsody, Windchill, Simulink, GitHub, Jira, Jama, and MySQL. And the chord lines represent intermodel connections. Like the Connection Summary table, it provides search and filter capabilities. For example, turning off all Jama connections. The chord plot provides a quick visual display of what tools are connected and how densely. In addition to the intermodel connections, there are intramodel connections. For example, within the SysML model. A quick scan of the Rhapsody diagram shows compositional relationships between blocks, containment relationships between requirements, and satisfy relationships between blocks and requirements. These also form part of the total system graph, and Sade can also display these connections. For example, if we right-click on the flight software block in this SysML diagram and choose Sade, Visualize, View Neighboring Artifacts Auto Layout, this shows the flight software block, circled in red, to indicate the starting point, plus its nearest neighbors, a GitHub file, a SysML block representing a flight controller, an electronic component the flight software is allocated to, and a SysML requirement, autonomous functioning, that the flight software satisfies. Now, any of the neighbors with a green border can be expanded to show the rest of its nearest neighbors, if any. In the case of the flight controller, this includes a Simulink block and another SysML requirement that it satisfies, which is further linked to a Jama requirement. Expanding the autonomous functioning requirement shows a lot of new elements because it has a Jama connection and 8 SysML subrequirements, each with its own Jama connection. Such rapidly expanding models may be more easily understood in a tree format. Now, if I choose the same block and right-click Sade, Visualize Tree Layout, we can progressively expand the same structure, but only growing right to left. Now, the tree layout also does not display certain SysML dependency relationships that flow upstream with respect to the tree. Sade 3.1 has introduced its own back-end database for managing connections. Check for videos in the Visualization section that demonstrate new queries for tracing connections across large graphs